Okay, first video on the 30 horsepower rotary phase converter. This one's a bit more complicated than my usuals. This one I've got an input contactor, and I've got my starting contactor, and I have my output contactor. And the timer controls these two contactors in opposition. So one is on and one is off. So my input contactor, I'm going to have switches like this all over the shop, and maybe just two, not really all, maybe one in here and one out by the machines. And this is going to turn on this contactor and turn it off. Reason being, instead of just turning it on and then just, being out here forever, is because it's a 30 horsepower, 3600 RPM, three-phase motor. And idling, it pulls right in the neighborhood of like 4,000 watts, just idling, just sitting here doing nothing. Just this is trying to balance the voltage so much that it actually turns into basically a 4,000 watt heater. So you don't want that just sitting there just heating up for hours at a time while you may or may not be using it. So I'll have, instead of walking in here, starting it up and walking out, starting it up and walking out every time I need to turn on a machine, maybe I'll, I'm doing a setup. I don't need to be out there having this thing just running as a 4,000 watt space heater. Now when there's a load on it, this motor, then it's nice and happy, it's balanced. That ghost leg that I'm trying to generate, there's not a ton of current going through there. So it actually cools down when it's under load. So I still have to put in all my caps. The black ones are the start caps, and these are the run caps. And got a couple more up here for balancing. So I'll put all my balance caps over here, all my start caps over here. I think I should buy a couple more per the math. But basically, when I push this button, it energizes this contactor. From here, it distributes out to the distribution block. From here, it's going to go down to the pony motor, the top lugs. The bottom lugs, they power this relay. And then this relay then jumps up to its double pole, double throw relay. And this is a on delay switch. It's 220 volts coil, but essentially it's taking that 240 volts and passing it through two of these terminals. So as soon as it gets power, it is going to automatically pull this guy in right off the bat. This will be pulled in because it's going to get power right away. Then after a period of anywhere between 0 and 1 second, depending on how long it takes to spin this motor up, I think it's somewhere in between, then this timer will time out and it'll switch its position, pull the start capacitors out of the circuit, and then it'll energize my output contactor. This way, for some reason, like my mill's the only one out there that doesn't have a motor starter, magnetic motor starter. So if my mill's on or something, it won't try to start my mill at the same time it's trying to start the rotary phase converter. So as soon as the start capacitors are pulled out, which is when the pony motor's at full speed, it'll then start outputting. And I can turn on my machines as normal. The other reason why I want to do this, so there will be, I guess, another one, is I'm going to hook this up to my air compressor as well. So this way, when it calls for air, I can just leave this thing on all the time, like 24 hours a day. And when my big 120 gallon, 12 horsepower Kellogg air compressor calls for air, which shouldn't be that often, during the winter time I use it to supply air to my furnace. The used oil furnace burns it, uses air. This little 5-horse behind me turns on maybe twice an hour for 2 minutes at a time, but you got to supply it with air. So if I hook this up in series with the pressure switch for the motor starter on that, when it calls for it to turn on, it'll signal this. This will turn on, send power out once this motor's started, run the air compressor until it no longer calls for it. The call will then be terminated until this is shut back off. So all of this stuff will only turn on by itself when needed when I'm running the air compressor. Now, if I already have the system on, well, being that these are in parallel, it won't care. It'll just keep running. If I'm running the lathe, that air compressor will kick on as it needs to and shut off because the power will already be there. And all the controls will just be in parallel. So next, I'm going to hook up the pony motor and the start caps and see if I can't get this thing started, and then I'll start working on getting my gauges hooked up. And those basically just twisted pair over to the terminal block also. And then I'll start putting my balance caps in there and getting all the voltage squared away. And I got to get on the ladder and start running my my control wires. So that's that. So let's go ahead and turn it on. Nothing's going to start, but you'll at least hear the contactors. So right now it has power. Okay. So this little guy right here. This also has a light in it, so I might run a 4-wire just so I can get power to the light. So what that was these two pulled in right away. And then this one disengaged and that one engaged with a 1-second timer. I think I have the timer maxed out right now. Yeah, 1 second. And that was me just hitting the stop button. So start. See the timer light too. When the other light comes on, that's when it's actually telling it to switch. And off. Good.